Okay, welcome to the online version of 10.5 Notes. Objective: Buckingham students will use properties of tangents and solve problems involving circumscribed polygons. Okay, we learned what circumscribed was last lesson, and now we're going to learn what a tangent is. A tangent is a line that intersects the circle in exactly 1 point. So, if we have a circle here, and we have a line that comes by, and it just gets really, really close and touches that circle at one spot, and then it keeps going. So I know it looks like maybe it's hitting at more than 1 point, but that's just because the thickness of our lines here is so great that we can't really see that one little spot where they intersect. But in theory, if we were to zoom in and zoom in and zoom in and zoom in, it would just always just be one little point where the circle intersects with this line in order for it to be a tangent. Okay, and so our theorem, 10.9, that deals with tangents, says if a line is tangent to a circle, then it is perpendicular. And remember, perpendicular means at a right angle to its radius drawn at the point of tangency. Okay, so wherever this line intersects with the circle, it's going to be perpendicular to the radius at that point. So now that we know that, let's take a look at this first example. They say connect N and B, making triangle NAB. Okay, let's do that. So I'm going to just kind of sketch this little line right there. And now, sure enough, look, we have triangle NAB. And it says if NA is 3, so let's just make this 3, and AB is 4, we're going to find this distance of NB, and let's just call it X, okay? So we have a right triangle with a side 3 and a side 4. Well, hopefully right away you're seeing, hey, that's a Pythagorean triple, 3, 4, 5. And that's because 3 squared plus 4 squared, if we were to solve for x, we would end up with 5. Let me show you. 3 squared is 9. 4 squared is 6. I don't know why I wrote 14. Okay, sorry about that glitch there, but we get 9 plus 16 equals x squared. 9 plus 16 is 25, and 25 equals x squared. You take the square root of both sides, and you get that x equals, apparently I cannot write right now, but you get x equals 5. Let's write it again, x equals 5. And yeah, that's the Pythagorean triple that we're talking about, 3, 4, 5. Okay, so that's one that you want to memorize and just see it. So yeah, NB is 5. All right, well, let's go to the next slide. Okay, theorem 10.10 says if a line is perpendicular, let's zoom in here, I'm going to write perpendicular, to a radius of a circle at its endpoints on the circle, then the line is tangent to the circle. Okay, so we said, hey, if it's tangent, it's going to be perpendicular, and now we're saying if it's perpendicular, then that is enough information to also tell us that the line is tangent. Okay, so in this first example, it says determine whether MN is tangent. Well, we can determine if it's tangent by determining whether or not that's a right angle, and we can determine whether or not that's a right angle by determining whether or not this is a right triangle. In order for this to be a right triangle, it would have to satisfy the equation a squared plus b squared equals c squared. Well, let's plug this in. This would be my a, this would be my b. You get 3 squared is, actually let's not even do that. Let's just say a squared is, let's say my a is 3, so that would be 3 squared, plus my b is 4, so that would be 4 squared. And over here, you should see that if this radius is 3, then this radius is 3 as well. So put a little 3 there. Well, that means that this whole side here is 3 plus 2, which is 5. So our C term would be 5 squared. Well, we don't really have to do this. We know that 3, 4, 5 is a right triangle. It's a Pythagorean triple. That's one that we have memorized. And so is MN tangent? Well, yes, because we know that this is a right triangle because it satisfies the Pythagorean theorem. And if it's a right triangle, it's a right angle. And if it's a right angle, it's a tangent. So our answer would just be something along the lines of, yes, MN is a tangent. Okay. I want you to use the same logic to determine whether or not PQ here, and this is P, it kind of got cut off, determine whether or not PQ here is a tangent to circle R. So you guys are going to do that one on your own. I suggest that you pause the video, and then I will put the answer up. Okay, here's my work. You can see it all here. But basically, I went and said, hey, this is my A, this is my B. And since this is a radius, it's going to be congruent to this radius. So this is 4, and this is 4, and this whole thing is 8. So 4 squared plus 5 squared should equal 8 squared if it's a right triangle. Well, 4 squared is 16, 5 squared is 25, 16 plus 25 is 41, and 8 squared is 64. 41 does not equal 64. Therefore, angle Q is not a right angle, and PQ is not a tangent. And that's what you should have had. And this writing in black would be what your actual answer is, and the blue is just my work. Okay, let's take a look at the next theorem. It says, if two segments from the same exterior point are tangent to a circle, then they are congruent. And they are congruent. So you can see over here, I have two segments or lines. It could also apply to lines. But if two lines intersect at the same point outside of the circle, and they're tangent to the same circle, then that means that these two segments are congruent. We could say that AB is congruent to AC. Well, now let's use that. Here, I have two circles, and I have three tangents. Well, let's just look at this top circle here, okay? I have a tangent line here and tangent line here because it tells us to assume that all the segments that appear tangent to circles are tangent. So we know these are tangent. And if these two are tangent to the same circle and they meet at one point, well, that means that this line is congruent with that line. And on top of that, if these two are congruent, we also know that this line and this line are tangent to this circle R, and they meet at the same point A. So AB and AC are congruent as well. And we know by the transitive property that if AB is congruent to AC and AC is congruent to AD, we could just say AB is congruent to AD. And we have some values for AB and we have some values for AD, so we can set those values equal. So let's do that. We would have 6x plus 5 equals negative 2x plus 37. I'm going to subtract 5, add 2x, add 2x. Those cancel, and I'm left with 8x equals 37 minus 5 is 32, and x equals 4, because when you divide both sides by 8, you get 4. That's it. Pretty easy, right? All right. This next one, I'm going to just remind you of a couple things and let you guys figure the rest out on your own. Okay, it says triangle ADC is circumscribed about circle O. That means that all these lines are tangent to the circle. That's what it means. They want us to find the perimeter. Remember, perimeter means the distance all the way around this triangle if EC equals DE plus AF. Okay, couple of things that we need to jot down here. If all these lines are tangent, then we know a couple of things. We know that DE and DF have to be the same because they're just lines that are tangent to circle O and meet up at D. AF and AB have to be the same because they are just lines that are tangent to circle O but meet up at A. And finally, EC and BC have to be the same because they are lines that are tangent to circle O and meet up at point C. So, that's some important information. The last thing is they told us what the value of EC was. Remember, they said that EC is equal to DE plus AF. So if we can find DE and we can find AF, we should be able to find EC. So with all that information, I want to know the perimeter. Okay, I'm going to let you guys try this, and then I'm going to give you the answers. So I recommend that you pause the video now and check out the answers in a second. Okay, so I filled in the missing things here and here because I knew these things were congruent. So these two are both 19 and these two are both 6. And then I went over here and I said, well, DE is 6 and AF is 19, therefore EC is 25. So I filled in 25, and then that means that BC is 25 as well. And then starting here at point C, I just went and added all up. 25 plus 6 plus 6 plus 19 plus 19 plus 25. Wrote that all out. You could probably do it in your head. You could also just plug it in a calculator, but either way you should get the perimeter is 100. And that's what we're looking for, 100 units. Okay. This problem is going to be a little bit trickier, but I want you guys to try it on your own. It says find the perimeter of an equilateral triangle ABC. Okay, so we know something about triangle ABC. Circumscribed about another equilateral. Okay, so it just means it's outside another equilateral. I think that this language may not be correct, but it's circumscribed about another equilateral triangle XYZ. So let me show you what this has to look like. ABC would have to look something like this. Let's call this A, let's call this B, let's call this C. And it says that its XYZ is inside of it, where X, Y, and Z are the midpoints of the sides. So XYZ is going to look something like this. Of ABC. Okay, so I think that it's going to look like X, Y, Z. And it says the perimeter C. This is actually a typo. This shouldn't be asking for the perimeter of, or it should be telling us the perimeter of X, Y, Z, not ABC. So make sure you change that on your notes. So they're telling us the perimeter of X, Y, Z is 12. So this thing is 12. This perimeter here is 12. And we want to know the perimeter of ABC. Okay, they're both equilateral. So that tells us a lot about these angles. So I want you guys to describe for me how you would find that perimeter. Okay, so find the perimeter and describe for me how you would do that. And that will be your summary for today's notes.